Lesson 3, Functions. What will we learn today? To find the value of a function for a certain number, and to make a function table of values. Vocabulary startup. A function is a relation in which every member of the domain or input value is paired with exactly one member of the range output value. An example of a function is m is equal to 20 times n, where m represents the amount of money earned and n represents the number of lawns mowed. In this example, n is the independent variable and m is the dependent variable. So what do functions look like? They look like what you see here. So to find the value of a function for a certain number, substitute the number for the variable x. So we read this as the function of x, or f of x, is equal to 15 times x. So x is the output, the function is the output or range. This x is my input, and it could be any real number, and it is the domain.
Functions. Dina and Peter can buy DVDs for $15 each. They can make a function table to represent this situation. They start the table with a column to list the number of DVDs that are purchased. These will be the input values. They add a second column to list the total cost. These will be the output values. The total cost of one DVD is 15 times 1, or $15. The total cost of 2 DVDs is 15 times 2, or $30. The total cost of 3 DVDs is 15 times 3, or $45. The total cost of 4 DVDs is 15 times 4, or $60. The total cost of 5 DVDs is 15 times 5, or $75. We can see from the table that the total cost depends on, or is a function of, the number of DVDs purchased. A relationship that assigns exactly one output value for each input value is called a function. Functions are often written as equations. The input x is any real number. F parentheses x is read the function of x, or more simply, f of x. It is the output. In this case, we say f of x is equal to 15x.
Our first example, they're asking us to find the function of -3 if the function of x is equal to 2x plus 1. So what we're doing here is we're taking this -3 and we're going to plug it in for x. So we're going to say function of -3 is equal to 2 times -3 plus 1. Multiply 2 times -3, which is -6, plus 1. And so my function of -3 is equal to -6 plus 1, which is -5. So let's look at an example of a function table. Choose 4 values for x to make a function table for f of x is equal to x plus 5. So that's the first thing we're going to do. Choose 4 values for x. Then state the domain and the range of the function. Second thing we're going to do. So let's start with the domain. So the domain is going to be x, my rule, function of x is equal to x plus 5, and then my range is my y. So they want us to choose any 4 values. So I'm going to choose -1, 0, 1, and 2. Use the simplest numbers possible. So f of -1 is equal to -1 plus 5. So -1 plus 5 is equal to 4. Function of 0 is equal to 0 plus 5. That's 5. Function of 1 equal to 1 plus 5. That's equal to 6. And then last, I'm going to use function of 2 is equal to 2 plus 5, which is 7. So I used 4 values to find a domain and a range. Now let's state the domain. Domain is -1, 0, 1, 2. My range, four, 5, 6, 7. Now keep in mind, because we get to choose our 4 values, it may be different than someone else. But again, I tried to stay with the lowest numbers possible. So that's why I chose -1, 0, 1, and 2. Real world examples. So there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, Pj, or P of j, is a function of the number of jars of peanut butter purchased, J. So this is a 3-part question. We're going to start with number 3. Identify the independent and dependent variables. So I need to identify the independent and dependent variables. So we're looking at 2 different things here. We're looking at 770 peanuts, and we're looking at a jar of peanut butter. So we can determine how many jars of peanut butter we want, but we can't determine how many peanuts go into each one. So independent is going to be the jars of peanut butter. Dependent, so each jar is dependent on 770 peanuts. So I'll just say number of peanuts per jar. Okay. Again, we cannot change how many peanuts go in each jar, but we can change how many jars we purchase. Continuing with our peanut butter example. Number 4, what values of the domain and range make sense for this situation? Explain. So again, our domain is our independent variable. And we said that was the jars of peanut butter. So the value that makes sense, they will have to be positive numbers or positive values, and they're going to have to be whole values. We cannot have negative jars, and we cannot have half of a jar. That's for the domain. For the range, so the range is our dependent variable. And we said that was our 770 peanuts, or the number of peanuts. And so what's going to make sense is going to be multiples of 770. Because one jar is going to be 770, 2 jars, 2 times 770, and so on. So every number that we get for our range has to be multiples of 770. The last part to our real world example. 5. Write a function to represent the total number of peanuts. First thing we're doing. Then determine the number of peanuts in 7 jars of peanut butter. So a function that they're wanting us to write is pretty much an equation. Okay. The only difference is it's going to be function of x is equal to something. Okay. Function of x is just one example. It can be h of x. It can be y of b. Whenever you see two variables like this, that's going to be a function. So let's think of a function. So let's go, we're going to go f of j, because I'm going to use j for jars. Again, that's my independent variable, is equal to, and if you recall, it was 770 peanuts for each jar. So that's going to be my function. That's my first part. Determine the number of peanuts in 7 jars of peanut butter. So I'm going to say function of 7, because I'm taking 7 jars. Again, j represents jars, is equal to 770 times 7. So that's our function of 7 is equal to 770 times 7. And that's going to equal 5,390 peanuts. That's how much it will take for 7 jars of peanut butter.